Hello everyone. So today in this video we will talk about the unconditional branch and conditional branch instructions in ARM assembly language on the Raspberry Pi. So we will see how we can jump to one section to another section within our code section, and how we can apply then conditional branches to make different comparisons and decisions. So let's see. Let's see first the example for the unconditional branch, so that how we can jump from one section of code to another one. Alright, so I'll just increase the font here. Alright, so let's say I have a file. I'll just name it jump.s. alright, and let's see, I have a text section just for the time being, alright, and which I will just write a simple global main function. So here we go, and in main section, for example, I have just this instruction like move r0 comma and the immediate value, let's say we have 2. I'm moving value 2 in register r0. alright, and then I want to jump to another section which is of course not this section but some other section, and I will give it some name as well. Alright, so what I can do, I have the instruction b means branch to that particular section. So for section I can give a label name to that section, just like I have this label name main for this main function. So for example, I have this I can name it, for example, other underscore section. Alright, so this instruction, what will do, it will jump to other section address. So that address of this section then will be start executing from there. Alright, so for example, after this instruction, if I have some other instruction, for example, I have move r0 comma -3, so this instruction now in this case will be skipped, and this other section, for example, I have defined it here. Alright, so I will define it like this, just like I have defined this main here. So I will write other underscore section colon, and what I can do in this section, I can simply say bxlr, means just exit it. Alright, so what it will do is it will just move the value 2 into the register r0, and then we'll simply jump to this section which is having the other instruction of just exiting it. Alright, and the program will exit. So in this particular case, you can see that the program never will come on this particular instruction, although it is residing in the program, and you can see it in the memory as well, but this will never be executed in this section. Alright, so just in case if you want to test it, so let's see, we can save this file. Alright, and I can edit my main make file. Alright, so we can okay, so this is, I first need to jump into my assembly language folder, proc here, okay, and I can copy my on the previous, so this is the way to go to directly to the previous folder. So it will pick up this file and I will copy it here. Alright, now I can see my file here, so here it is, and then now let's edit the make file. Okay, so I can call it simply jump. So let's edit all this. This will be jump. Alright, and this is the jump.o, the first binary, and this will be created from the assembling the jump.s. Alright, and in clean we can remove the jump and all the other pointers. Alright, for make clean command. Okay, so let's run it. We can first run make clean. Alright, we don't have any .o files and any executable, and then what we can do, we can simply say make. Alright, so our file is created here. So on the first time we can just simply run the answer, so you can see the answer will be the 2 will be printed here. In this case it should be, so you can see the 2 is printed. Alright, so in case this value is something else and you want to see the different result, so you can edit the code. Alright, and for example I have, so here previously it was R02, so when the program exited, so R0 had this value too, but in case before exiting I just want to move the value something else, let's say 4, R0 comma 4, and I want to compile it. Alright, and now if we execute it, so the 4 will print. So you can see that we jump to the other section here, and this instruction was totally skipped because of this unconditional jump. So you can put any unconditional jumps wherever you want according to the logic of your program that you are trying to build. Alright, so we will also run this program in the GDB as well. See, okay, so you will see that the program counter is now here. The main role of the program counter is to update its value according to the jump instruction that you have given. Alright, so let's see gdb /jump. Alright, let's start the program. And there we go. Now if we disassemble it, we can see. Alright, so on the first other, so before the other section of that code, so we are seeing these particular instructions here. Alright, so if we just run them step by step, so we will see different answers. Alright, so for example, and we want to see the value of R15, how it changes when you make the jumps, unconditional jumps, or maybe the conditional jumps we will see in the next few minutes. So for example, I want to see the value of my registers. So we have here R0, and then other one is R15. So this is the program counter, if you remember. Alright, so currently this is the value of R0, and R5, the program counter, is pointing to at this particular address in the memory. So it's going to fetch this instruction into the memory and pass it on to the the circuit ALU, and it's going to execute. Alright, so let's run it. Step I. Alright, now the program counter value is now changed, so the 4 bytes should be increased. Alright, so if you see this now, you see the value 2 is moved into R0, and now the program counter is updated, so the next value is 103D4. Alright, so that's the new value is going to be executed here. So the next instruction here is jump instruction, so it's going to jump on this instruction. So this is the address that is going to move into the R15 register once this jump is made. Otherwise the next instruction is on the next 4 bytes, because one instruction takes 4 bytes, as this is the 32-bit architecture. Alright, so I will just, so if you want to see registers or the disassembly of this, so you see this is now pointing to this instruction, and my program counter is pointing to this, which is correct thing. Alright, now when I will execute this instruction, is going to jump on this address. How? Because the program counter is going to jump there. Alright, so let's run it. Step I. Okay, I want to see the values of my registers again. Now you see this is the new value of so the next value is not 10338, because if this instruction wouldn't have been any jump instruction, so the next instruction or the next program counter value should be this one. Alright, but this is not the case. Now the next value after executing it, the program counter value is 103 DC. Alright, so if you disassemble it, you will see the section, this other section, now we have jumped there. Alright, so you see 103 DC, and we have now this value which is saying move R0, 4, value 4. It means copy the value 4 into register R0. Alright, and now when you run it, alright, and again now see the values. Alright, so the next instruction is going to execute here is now this, because now we didn't have any jump instruction here, so this case didn't happen as in the case of jump instruction or the branch instruction. So now we have the next 4 bytes instruction address here, and that is going to be executed after this one. So this is already executed, and we have now value R40. So this instruction is just going to exit the program. Alright, so we know it's pointing now out there, and we can disassemble to see it. Alright, now when we run this from here, like say continue, because it's the long set of instructions it takes to. Also continue, and then after running, it is exited now. Alright, so I'll put it here. So that's how the branch instruction or the unconditional jumps can work, and we will use this with the conditional branch as well to make different logics. Alright, so let's see the conditional branches now. So before going to the conditional branch, any code examples, so let's see what we have here. So the CPSR current program, which is current program state register bits we have here, these are very important ones, the four most significant bits, because on the basis of these jumps are taking place, and that's how we can make different decisions upon the different values comparison. So this is to provide the comparison. Alright, so this instruction here, so this is not the instruction, so these are the bits. So the most significant bit of CPSR register is negative bit, which means if so this bit is going to be 1 if the last instruction executed that resulted the answer in some negative number. Alright, so this will set to 1, otherwise it will keep 0. Then we have 0 flag bit. So if last instruction is resulted in answer 0, so this 0 flag is going to set to 1. Alright, otherwise it will keep 0 because the answer didn't result in 0. So in the case of carry bit, this will set to 1 if the instruction generated some answer that also resulted in carry as well, or you can say the 33rd bit. So for example, in case of the 32-bit addition, you added two numbers of 32-bit, but then you added the 33rd bit generated, which is a carry bit. Just like in case of simple decimal numbers addition, we always sometimes the carry is generated, which is forwarded to the next numbers, and that is also added to the numbers. So if the addition results in the carry, or maybe any other operations, we will learn about the logical bitwise operations that can cause the carry flag to set to 1. Alright, because that answers result in the 33rd bit. Alright, so in that case it will set to 1. For overflow flag, this is going to set to 1 if the last instruction resulted in something that cannot be expressed in 32-bit 2's complement. So that number was very large. For example, division by 0 or division by two small number Alright, so there was a very huge number and the divisor was very small number that resulted in some answer which was basically resulting in some number that cannot be expressed by the 32-bit 2's complement format. Alright, so that's going to happen here. So how the different these basic conditional jumps, they are going to work on the basis of these flags values. Alright, so before these jump instruction, we normally have this value, this instruction, comparison instruction, CMP R1 comma R2. So what this instruction does, this instruction simply subtracts the value with each other. For example, this is going to do R1 minus R2. Alright, now upon this subtraction, might be if it result in the negative number, the negative flag can go to 1. If it results in 0, the 0 flag can go to 1. Alright, and then if there's a carrier overflow, of course it can reset to 1 as well. Alright, so for example, now the comparison has taken place. R1 is subtracted, R2 is subtracted from R1. Alright, so now what we want to check, for example, we want to check if these two values are equal or not. Alright, so we need to do some operation on the basis of that decision, some operation that we want to. Alright, so if you want to do some operation upon if these values are equal, so the instruction is BEQ. This means jump to some label name. Alright, if R1 is equals to R2, so we know that if the two values will be equal, the subtraction will result in 0, and in that case 0 flag will be set to 1. Alright, so and if you want to check if those numbers are not equal, alright, this means like jump to label, this means R1 is not equals to R2, which will result in 0 flag is 0. Alright, now for example, if you wanted to check the less than, for example, wanted to check the if R1 is less than R2, okay, this means that jump to this label if R1 is less than R2, which means n is 1, because this value was smaller, this was greater, so subtraction can result into negative value. Alright, and similarly then we have a BLE instruction, jump to label name if R1 is less than or equal to R2. So this will check if n is 1, if n flag is 1 or the z is 1. So if either of these cases here and the instruction is this, so jump will take place, otherwise it will not take place. Alright, and in the case of greater value, so for example, if we want to check R1 is greater than R2, then it is at the back end it is checking the bits as the n should be 0, the n flag should be 0, and z should be 0. Alright, and if the case is R1 is greater than R2, so there is instruction BGE, so that means n is 0 and z is 0. If this is the case true, that means it was greater, or z is 1. If one of these cases true, then this means this was a case of greater or equal, so just jump to this label name. Alright, so that's how these conditional branches are working. Alright, and just for the example now, we will run some code. Alright, so let's do that. So I want to make a separate program. I will name it cmd.s, and I have again some text code section here which has some dot sorry main and then we have here, so let's say we have this example here. So in main we have these instructions, so I'll say move R1 comma 2, alright, and then I have move R2 2, alright. So we have these values, the similar values in R1 R2, alright, and now I want to compare them and make different decision and jump to different section. I want to do that, so let's compare them. CMP R1 comma R2, alright. So now after the comparison I want to say that, and I want to execute like if this R1 is equal to R2, alright, then jump to the case which is equal, alright. So I will say equal case, alright, and in case the case is different, alright, I'll say, or for example I want to have this instruction of EGT, then I will say this means if this one the R1 is greater to R2, then exit to or then jump to the section which is greater case, alright, and else I want to execute if the case is less than, I will say means R1 is less than R2, alright. So I'll say lesser case here, alright, and now I can because I have the possible, I have put the jump instructions of these possible cases here. So now I want to define these sections here which are doing the, let's say, different instructions in their sections. So let's do it now. So for example, first I have this equal case label section, alright. What I can do here is move R comma 2, alright, and once this done I want to jump to a section which name is exit, and this will just exit the program. So alright, so I'll just say B exit, alright, and here I can define the other case which is the greater case, alright, and I will say here let's move R0 comma R3. So I'm giving different values here to see the result, like if we with the password, if we change the different values here, so the particular section should be executed, alright. We'll see that. So and once the value is moved here, I'll say just jump to exit section which will exit the program, and then I have this lesser underscore case which has move R0 comma h4 value. So if the case is equal, value 2 will be moved to R0, alright. If the case is greater than, means R1 is greater than R2, then R0 will hold the value 3. 3 value will be copied here, and in the case of the lesser case, the value 4 will be moved to R0. Alright, and we don't need the another exit instruction here, since everything executes line by line in assembly language. So you can simply define it here, and what will do, it will simply exit the code. Alright, so bxlr. So, and even if you put here an extra jump instruction here, so still it doesn't make any difference, because exit is just on the next line. Alright, so that's why we don't need this instruction here. Alright, and even if we do it will still work. Alright, so now and in case of equal, you can see that when the value is moved and the program has to exit, so we have applied here the unconditional jumps. So this will make unconditional jump to this section exit, will have the terminating, or you can say the ending instruction of the program. Alright, in both of these cases. Alright, so that's how it's going to be done. So I'm going to save it. Alright, and I'm going to edit my make file as well. So instead of jump, now I have cont. And this is con.o. Here this will be con.s, and this is here is going to come, that is going to be deleted on make clean. Alright, so I'll save it here, make clean, and then make. Alright, so here we have the executable, and now it's a /con. So let's see the first result here on this console, and then we will move to the GDB as well. Alright, so /cont, and we have the value, let's say we have echo, we have the value 2, because here, sorry, that's wrong. Because here these values were equal, so this was the case of equal. Now for example, if I want to change the value, I say the 3 should be moved to R2. Alright, so in this case, which case should be executed? This one. So I should see the value 4 when the program exits. Alright, so I'll try it again, and we'll run this again. So you can see now the lesser case is executed. Alright, so the decision is correctly executed. I can see the 4 value. So this means this particular section was executed, which was correctly which was the correct one. Alright, and now if I want to check if the greater case is working or not, so I'll just move this value here to 4. Alright, and I can then save it just like it and compile it. Alright, now when I will run it, so I can see 3. So that means the cases are being executed correctly upon different values of R1 and R2 in this program. Alright, so now if I want to run this program in the GDB, so gdb./font. Alright, so I can say start, and disassemble C. Okay, which values do we have here? Alright, so this is the instruction. You can see these first 6 instructions of the code, and these code sections, they're not showing it here, but of course whatever the case will be, after this comparison instruction, it will jump to that particular section. And this section again, it has its own you can say this address where it points to, so the program counter should be updated according to the case to case. Alright, so in this case we saw that this is the case of greater. Alright, so this one should be executed. Alright, this branch should take place. Alright, so, and before that we want to just make sure what are the, before executing, what are the values of our registers. So we have R0, R1, sorry, R1, R2, and we have R15 because that is the program counter. Alright, okay, so we can see it's pointing to the first instruction, and then these are the values we have currently at this moment. Alright, so now I will execute the first instruction. Alright, and the values is this 4 in R1. Alright, I will execute it again, and now the value in R2 should be changed, so this is now 3. Alright, and now so my R15, where it points to 1038, which is D3 so this is the instruction. Now it is going to make comparison between two by subtracting these two values. Alright, so I can see it here in this assembly, or it's there, it's pointing to, so now this is going to execute. Alright, so if you want to see the value of CPSR, so if I just say info registers CPSR, so this is the value, and DG, this the last nibble, so this is the most significant 4 bits. So of course in a hexadecimal format you can see, because each hexadecimal number, that is a nibble of 4 bits actually. So currently it is it's saying it's 0. Alright, and these 4 bits are basically showing that format of NCV values. Alright, so according to this where the jump should be taken. Alright, so again this instruction will be executed, the case will be checked. So alright, so this will not be executed because the values are not equal here. Alright, so it is first going to check if this is the case is true or not. Alright, so if you see step I, alright, and see, okay, so it has gotten to the next instruction. So this jump hasn't taken place because the case was not of equal. Alright, and now the case is basically of the greater value, so because the 4 is greater than R3 and R1 is greater than R2 in this case, in other words, so this one will be executed, this should be executed. Right, so now when I like say a step I, so this is going to jump here. Alright, so step I. Alright, so you can see that previously it was when I was keep running the instructions using the step I, so it was showing that this address in main, and like the program counter is updated to this address in main section. Alright, but now you can see it has jumped to this address and it is in this section particularly. Okay, and now if you want to see the values of the registers, alright, and the CPSR, so same value that was 4, alright, which was here, and because that is the fact that has taken place after the comparison instruction. So you can see now that the R15, because this is the section, okay, which is here. All right, and if I say disassemble now, okay, so it is pointing to this particular address, which is which comes under this function, or the section, you can say, greater case. All right, just like as shown here after we execute step I. All right, so now when I say step I, all right, and now I want to see the values. All right, so I can see that the 3 value has moved into this value 0 just because of this instruction here. All right, and the next case, you can see the next instruction is going to execute is this, which is the basically jump to exit. So again, this comes the unconditional branch instruction or the unconditional jump instruction, because it's saying that okay, we have done our task, we have moved the value 3 upon, because the case was of the greater values, the R1 was greater than R2, so now we want to exit from the program. So jump to this this section exit, so we can exit from there. All right, so when this will be executed, so it is going to jump into this section exit. All right, so let's say, and in case if you want to again see that where it's pointing to, so here's the pointing to. All right, and you can also see that this is the updated value of program counter here, because this section is going to execute. All right, so I will say step I. So now jump to this address because of the jump instruction, which is now in exit section. All right, so 103 FC in exit. All right, and again if you want to see the values of registers, all right, so R15 is 103 FC now. Okay, and where now it's pointing to what instruction you want to see it. So this is the instruction that is going to execute, that is coming under the exit function or section, you can say. So from here I can type simply say continue, so this will be executed now. All right, so what I can do now is want to check the other cases with the with the other values. So what I can do is that I can change the value right here on the runtime by assigning different values to my registers here. All right, so if you want to change the values at runtime in the debugger, let's see what we can do. So let's start that again. All right, and just assemble it. Okay, so now for example if I execute this instruction, all right, so the R is the R1 is basically have the value 4. all right, so I can say for registers R0 R1 R2 and R15 and CPSR. Alright, so currently this is the bit status of these values. Sorry, this is the status of the NCV bits in the last 4 bits. Okay, it's CPSR. Okay, so and the value 4 is moved to R1, but let's say I want to change this value right here on this before executing this instruction, which is the next one. All right, so before moving to this instruction, what I want to do is that I want to set value 3 and register R1. So I can do is that p $R1 set to 3. Okay, so now if I want to check the registers values, so R1 should have 3. Okay, so we can see the value R3 is moved here. Alright, And now when this instruction is going to execute, so R2 will also have value R3. Alright, so we can see that now both of these values are R3. And where are we at right now? As at this address 103D8, which is now a comparison going to take place. So when I will execute it, so the case is now basically the equal case. Alright, so the equal case should be executed. Alright, so this time this particular instruction, when it will run, so this case will be true and it will jump to this particular section which is equal case. Alright, so let's make sure we have written this instruction to be executed, and we have this particular address in the program counter here in R15. So here we have. Alright, so now I will say step I. Okay, and now you can see it is saying that it is on 103E8 address, and which is in equal case section of function. Alright, you can see that. So now if you say disassemble, alright, so you can see that you have moved to equal case instruction, okay, which is basically moving the value 2 in R0 register. Alright, so when you're going to exit it, when you're going to run it, so you have executed this instruction now, and if you want to see the values of the registers now, you can see the value R0 has moved into value 2 has moved into R0 register because these two values were equal. Okay, and now the last in the last register of particular this section, equal case section, is going to execute, which is this one. So this is again going to jump to the exit section, so from where the program can get exit. Alright, so when I will say step I, so as you can see it's in this particular address and the exit function. Alright, you want to see the last instruction, so this is the section here, exit, and we have just this last section, so I can continue here. Okay, and the program is exited. Okay, and now for example we can start again and we want to test the lesser case, if it is true or not. Right, so again we can disassemble it. Okay, you can see here. So what I'm now going to do is that this time I will move the value 2 into this particular register R1, so that the less case should be true and this will be executed here. Alright, so let's first execute it. Alright, and then because I know I have executed this instruction, so R1 is now have value 4 here. Alright, so I can always see here on for registers R0, R1, R2, R15 and CPSR. Okay, so we have value 4 here, and again I want to change this value of this register, so I'll say $R1 set to 2. Alright, and now if I will check the values again, so I have value 2 here. Okay, and this instruction is still going to be executed. Alright, so when this will be executed, we have the value 3 in R2. Alright, so let's run it. Okay, now check the values of registers. So we have value 1 in R0, R1 we have value 2, R2 3. So when the comparison will now take place, so this case should be executed after this instruction, which is the comparison statement. Alright, so comparison hasn't taken place. Alright, so the bits will change when the comparison will be comparison instruction will be executed, because this is going to result in the negative bit. Alright, so the negative bit is the most significant bit, so we should see 1 here. Alright, at least, or we can infer that the value here for the least significant bit is should be 1. Alright, so let's do that. So first again I'll see where it's pointing to. So this instruction comparison statement is going to execute. So let's say step I. Okay, and now I want to see the values of my registers. So again the value is here, you can see is now updated. This value was this value previously, and now it has this value. Okay, and when we run this, okay, it's still in main because it has come, because the this instruction was not it was executed but the jump didn't take place. Alright, because the case was not for equal, so it has come to this address. Alright, you again step I, now is pointing to this address. Right, you can always see by disassemble command. Alright, just nothing. So it has come to this particular section there. Okay, that this should be executed. So this will take to the lesser case. Okay, so it has jumped up to the letter case and it has the address 103 F8. Okay, now if you want to disassemble it again and see, now that has taken us here. Okay, the lesser case. And if you remember that the last exit instruction was just after this instruction, so that's why we cannot see any other unconditional jump instruction here, because we didn't put there on the first place. Alright, so when it's going to execute, okay, and now R0 has value 4, and you can see after doing step 5 it is in exit section because we defined the exit section as well. Alright, so let's first check the values of the registers. Okay, so we have this values here. Okay, so R0 has now R4 because that's the true case. Was there the values was less because we changed the value of R1 at the runtime. We put the value 2 here in R1. Alright, and now if we just disassemble it, so we are in exit function, and it has the last instruction to exit the program. So I'm going to execute it, sorry, I continue, and this is going to execute. So this was the scenario that how you can make decisions upon different comparisons, by comparison between the different, like how you can jump to different sections over the different comparisons if the values are greater, equal, or greater than or equal to. Of course you can see rest of these, you can always test these jump instructions as well. I haven't covered in this particular code example, but of course you can do that once you have the idea how these ones are executing, and of course you can do that as well. Alright, so that was all for today. So I hope you can understand this concept of branches, unconditional branches and conditional branches. In next video we will talk about and see the examples for loops, that how we can run like particular set of instructions repeatedly over the number of times, and of course we will see how we can do the traversing over the arrays, like how we and with the loop, with the help of loop instructions, because these instructions are going to help us in building the loop structure, and that loop structure we can traverse our arrays as well. Alright, so that what we will see in the next video. So thanks a lot for now, thanks for watching the video, and please subscribe to the channel. Alright, thank you, bye.